Hello, students. So this is basic probability. Cam can't figure out what to eat. He's going to randomly select a piece of fruit from his pantry. There are 4 apples and 5 bananas in the pantry. So what's the probability that he selects an apple? Well, there are 4 apples. There are 5 bananas, so there are a total of 4 plus 5 are 9 pieces of fruit. So probability is always part divided by whole. So in this case, it would be 4 apples. That's the part that he's interested in, divided by 9 pieces of fruit. So 4 9s. In this particular one, it says you can leave it as a fraction. So I'm going to do that. And we'll check it. And we got it. Yay. So we'll go on to the next question. Spinners are a common source of questions for probability. This one, you spin the spinner shown below once. Each sector shown has an equal area. And then we want to find what's the probability of finding an area that's not shaded. So we got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sectors. Every other one is shaded. So there are 6 that are shaded, 6 that are not. So our probability is going to be 6 out of 12 for not shaded, which is the same as 1/2. So we can put it in as 1/2. We could also put it in as 0.5 or as 50%. Yay! Here we have another spinner. 4 different colors. Looks like each one is equal. So the probability of being blue, well, there's 1 out of 4. And if we did divide that, we get 0.25. So we can put it in that way. Or we can put it in as 25%. And that's also correct. You draw a card at random from a deck that contains 3 black cards and 7 red cards. What's the probability of drawing a black card? Well, there are 3 black cards. There are 10 total cards, so probability would be 3 out of 10, or 0.3, which is correct. Now, if we were looking at a regular deck has either red or black cards, but there are just as many red as there are black, so it would be a one half, or 50% chance of getting a red card or a black. But this is a very small, uh, strange deck. Okay, here we have a spinner divided into 5 equal sections. What's the probability that it's shaded? Well, there are 2 that are shaded blue and 3 that are not shaded at all. So the probability of it being a shaded section would be 2, that's the part, divided by 5 total. So it's always part divided by whole. Okay, so that's simple probability. Of course, they may throw in there just to try to trick you. Here, you roll a fair 6-sided die. What's the probability that you'll roll a number that's greater than 6? Well, there are no numbers greater than 6, so the probability of this is 0. This is a special case of what we call impossible. 0% means it simply cannot happen. If you had something like the probability of rolling a number from 1 to 6, that would be 100%. That's considered certain. The other problems we're doing this week involve the counting principle. So Paula is going to choose the size, color, phrase, and picture for a birthday card for her friend. There are 2 sizes, 4 colors, 7 phrases, and 4 pictures for her to choose from. So there are 2 different options that she can choose for sizes. Once she's chosen a size, there are 4 different colors she can choose from. So already we have 2 times 4 or 8 possibilities. With the basic counting principle, we actually end up multiplying how many times each of these different events can happen. So we'd have 2 sizes times 4 colors times 8 phrases times 4 pictures. So 2 times 4 is 8, times 7 is 56, times 4 would be 224. You can use a calculator for yours if you prefer, but I'm going to try that and see if I got it right. Yay! Awesome. William is drafting his fantasy baseball team because there are no actual baseball teams playing right now. He needs to select 1 player for each position. The following table shows how many players are available for each position. So point guard, he has got 10 to choose from. Shooting guard, 12 to choose from. Small forward, 7. Power forward, 2. Center, 9. So I'm going to use a calculator for this. I'm not going to try to do this in my head. We're going to have to do 10 times 12 times 7 times 2 times 9. Of course, the calculator is going to get in the way, but you can drag it over. So we have 10 times 12 times 7 times 2 times 9, which is 15,120. That's a lot of possible combinations. 15,120. And when I check that, well, you got it right. Good thing they had a calculator. Billy's picking a sandwich, a snack, a dessert, and a drink for lunch. He can have a ham, turkey, or salami sandwich. So there are 4 types of sandwiches. An apple, banana, or carrots for his snack. So 3 types of snacks. A cookie or a brownie, 2 types of dessert. And apple or orange juice for his drink. So 2 types of drinks. So you have 4 types of sandwiches. 4 times 3 types of snacks. So 4 times 3 is 12. Times 2 types of dessert would be 24. Times 2 types of drinks would be 48. Again, you can use a calculator if you prefer. Which I probably should have, because apparently I didn't do this right. What did we say we had? We had 4 times 3 times 2 times 2 is 48. Isn't that what I put in? Yeah. Well, obviously I made a mistake here somewhere. Okay, well, good luck. I'm sure you'll do better than I just did. Okay, so there are only 3 types of sandwiches. I was thinking of what I had in the fridge. So I've got 3 times 3 times 2 times 2, or 9 times 4, which is 36. Let's try that instead. And that's it. Okay, so good luck with this. I'm sure you'll do great, and have fun. Bye.